Hi everybody, welcome back. In the last video we learned how to do simple modeling in CloudCalc, which was simply done by typing in data in the datasheet, pressing page down to build each of the elements sequentially. Today we're going to do something, we're going to learn a style of editing that's a little more powerful, a little more flexible, and probably a little bit more fun. We're going to build a system by editing graphically. We're going to start by building this system you see here. It's the one that we pulled in as a pre-built model, and we'll learn the most efficient way to do this simply by drawing things up using graphics commands and in the graphic area of the CloudCalc. So take a look here. Hopefully we can remember what this looks like as we build it. Let's begin. First thing we want to do is go into the tools configuration, and this is going to be in the metric system, so let's make sure that we have the correct set of units chosen. We want to use metric 1. You want to do the B31.3 code. We want a node increment of 10. We want to auto-generate our bend nodes at the 0 point and the midpoint of bends. So you should be set up like this, and then we save our configuration. Also, as far as members are concerned, we're going to need a 4-inch standard, a 6-inch standard, and an 8-inch standard pipe. So make sure that they're in the list. And our material, I believe, is going to be A53B, so make sure that's in your list. If it's not there, if they're not there, go into your catalog and add those pipe sizes and those materials to your drop list in the way that we have shown how to do that in earlier videos. Okay, let's start and use we want to set up a new model. So pick new, give it a name. I'm going to call mine new. You can call it whatever you want. It says I already have one, so I should, it's warning me that I'm going to override it. That's fine. So let's begin. We can draw directly we can start modeling graphically in the graphic area right off, but let's start with typing in one element. First element, we're going to model a flange in on the data sheet. So that's 100 millimeters in the Y direction. It's a 6-inch pipe, A53B material. That's fine. Insulation, 125 millimeters. Insulation density, 0.000176 kilograms per cubic centimeter. Corrosion is 1.5 millimeters. We're going to make this a flange, so click valve and rigid and give it a weight, 150 newtons. Based on the relative length to diameter, you'll should draw it as a flange, but if it draws it the wrong way, which is its default, you can go down and force it to draw it a certain way. We'll see how it looks before we decide if we need to change it. Restraints, we want to put an anchor on the from node. In reality, it might be an applied displacement. You could put that in a similar manner here. We want to give it a temperature. It's 450 degrees C. We want to give it a pressure, which is 3,500 kPa. Pressure case 1. Save here. Fluid contents, I believe it's a 0.8 specific gravity. So we go 0.8 specific gravity. And we can now press page down. The element processes, and we have a flange drawn here. Now from this point on, we're going to draw graphically. We could continue with the page by page. And again, these two methods can be mixed together. You can draw things graphically. You can draw things, enter things on the page simply by opening and closing this, as you need more or less area. Okay. How do we build this? The next element we want to come up to an elbow is going to be 230 millimeters up to an elbow. We want to model something. How do we do it? We want to use this quick entry, which is enter an element from the graphic screen. Quick entry, click here, or any command. This is a right click, brings up your context menu all the time, or you can go to the graphic editing menu if you don't have a mouse, such as on a tablet, or if you just don't feel like bringing up the context menu. quick entry here, or we can use a hotkey, which is Q. Press Q, it brings up quick entry. Press Q again, it closes this. So you can bring this back and forth as you see fit. We want to type in a length, 230. If you do a length, it'll continue in the same direction. If you want to change direction, type it in here. We can hit enter, and we now go on to the next element. Now we're going to go 6,000 millimeters in the X direction. There's going to be a bend there, but by typing enter, it automatically adds that bend. And if we look on this, it added the intermediate nodes, defaulted to long radius, etc. So let's go back here, go quick entry again. Oh, and just notice that we have the wrong element here. It's going to start at 30. Why? Because we had this selected. So just close out here. You can start with any node you want. Do nodal select. Grab this end node here. Do quick entry. We're now going 40 to 50. So we want to go minus 3350 in the Y direction. Bend is automatically generated with, as you see, with the intermediate nodes. We can now continue on in the minus Z direction is minus 5900. Hit enter, and then we're going to go up in the plus Y is 2550. Continue, and then in the X direction, we'll go 330 millimeters. So now we've built the general gross coordinates of the system that we want to put in, and we can now start breaking this out. We can put in T's and valves and other things like that, reducers and things like that. So how do we do this? We want to start, we can break. Let's start by doing a copy here. We notice that this riser here is going to be duplicated 2 more times. So we can press E, or we can click this select elements. We press E, highlight select elements by window, and we grab these, and we want to copy these down. Right click, or we can grab it off this graphic editing window, copy array. We go copy array. We want to make 2 more of these. So we're going to have 3 of these in total. So we want to say there will now be 3. If you type in 2, you'll only get 1 additional copy. We're going to copy these in the Z direction. The first one is going to be 1600 millimeters in the positive Z, so we type 1600. And if you just type that, it'll duplicate the 3 1600 millimeters apart. But if we want to change the distance between them, we can say comma and 2700, which is the next one. If you have more than 1 of these, you could say 2 at 2700 or something like that. We'll see more of that. The format is laid out here in this little tooltip help. But if we say OK, we now copied this. So we've created our 3 risers here. So next we're going to do our break to start putting in our other types of elements. So I'm going to click this and break it. And we're going to have a run of pipe leading up to a T, another small piece of the T, we're going to have a reducer, we're going to have a valve, and then we're going to go down to the end here. So in this case, I highlight that item. I say right-click for the context menu. I say break, and I could say how many equal number nodes. If I say 6, they'll all be the same length, or I can specifically say break it at this many different lengths. So my first piece will be 2650. My next one, I'll have 2 that are 150 each, so I say 2 at 150. I'm going to have a valve that's 1100. And then I could say the last piece is 1950. I could say make it 1950, or I could just, whatever's left over will go into that last part. So if I say OK here, we now see it's broken. So this is the first piece, second piece, third piece, fourth piece, and fifth piece. And if you're curious, did it get the lengths right? We can go up and check it's 1950 as we thought. Okay, so that's good. So next we want to grab this piece here and do something similar, break it down. So we'll go here, right click, break, and my lengths are going to be 305 150. You don't give it a sign, even though it's going downwards. It means from the start node, the from node to the to node. 350. Then my valve is 925, and then it'll be 370, and then we have 2 at 350, and the last piece should be 530. So if we say okay to that, let's check this piece here. Did it get it right? If I check my dimensions, I'm sorry, it's 550. I can't remember that well. And now we'll break here. This piece we're going to break, but it's also going to be broken the same way this piece is. So if I control double click, I've got the 2 runs here, and I'm going to put a valve in the middle, and I do a break, and I say, let's make this now. I want to make this 500, and then 600, and then whatever's left over. So now I broke both of these the same. And now I've got this piece. Okay, this piece, click, control double click, and this piece, they're all going to look alike. So I say break and make it, what do I want to make this? I want to make this 550, 350, or 2 at 350, sorry, 2 at 350, and that looks good. So I come here. So all of these got broken the same way. So now if I look at this in X view, I see that these things have all lined up, and we have a 4-inch pipe running from here to here. Now I can build these, draw these in. I can go to this draw mode. This is D, where I click this draw mode icon here. I say I want to draw from here. It builds a little circle around this node down to this one, page down, and it registers. I go here, click here, I get the little circle showing I'm drawing from that node down to this one, page down. Okay, that looks good. So now I put this back in 3D mode. I've drawn all of my pipes. I just have to do things like change the types and the sizes and things like that. So now I'll select my, I'll create my valves. So this one's going to be a valve. Okay, put myself out of draw mode here. Okay, so select here, control click, double click, control 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 double click. These are all going to be valves. I can now right click, say element type, valve or rigid. I click the box. We want to designate these as such. I give them a weight, 3,000 newtons or whatever it may be. I say okay. We now have all these valves. Now I just want to designate where the T's are. I'm going to put them at the 2 nodes of each of these elements. So in this case, I want to double click or select the elements running into a T. So that would be here. Double click this one, control double click this one, control double click here, 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 here. I believe that's got all my T's. So I can right click and say element type T or SIF, check the box. It's going to be at the 2 node. We'll call this out. Let's say there's a welding T there, so we'll define the welding T. So now we've got our T's, we've got our valves, we've got, we want to put some flanges and anchors on the end here. So let's go into Y view, and I'll turn off the nodes for a moment. Let's select elements by window and just grab the end of these items here, highlight those. I want to break those, so I'll right click, break, and I'll break those at 230. Say OK. Now I want to turn these into flanges, but actually you can't really see here, but both pieces that broke are still selected, so we have to reselect. So let's just grab the ends here, the part we're going to turn into flanges, which are here. Go down, right click. We call it element type, valve and rigid. Give it a rigid element, 150 newtons weight, and select here, we should see the flanges. And now we're going to add anchors here. And in order to do that, we have to select nodes, because you can edit, if we have node select, you can edit anything that has to do with that, which would be things like moving a node, adding a restraint, adding a spring hanger, adding a concentrated load, adding a displacement. If we've selected node like element like we've seen so far, it's things like copying those elements, changing the element type, things like that. So let's go and switch this into node select mode, which is pressing N as a hotkey or selecting this box. Let's display our nodes again, and let's zoom in a little bit so we can see what we're doing. And now we want to grab, let's go node select, we want to grab node 140, control grab 110, and then 80, and it'll turn color orange, making it selected. So now when we do right select, we've got a different context menu here. If we've selected nodes, only things that can be done to nodes will be here. If we've selected elements, only things that can be done to elements are there. So we want to add restraints or hangers. Let's go restraint. Let's add a restraint here, an anchor at that node. That's fine at those nodes. So we say OK. And we look in 3D view. We now have nodes, the anchors there. Let's go and put a spring hanger on this. Or let's put a, we want a wide restraint at the bottom of that rigid. Select nodes here. Grab 49. You see it turn orange. Right click, restraints and hangers, go restraint, and add a restraint. And at that location, we'll put a plus Y. And maybe we'll put friction, 0.3 friction factor, and save that. So we now see the restraint here. And we want to add a, so go P to put us into pan mode, and zoom in. We're going to put a spring hanger up here. So N activates the node select. Let's grab this 39 here. It turned orange, say it's selected. Let's go and say spring hangers. We go hanger. We want to click that there's a spring hanger there, and we can choose the hanger catalog. We've got a couple in here. Other information, fix how many hangers you have there, additional weight, etc. So we do this. We've now got a spring in place. And now we just want to do some other things. We want to change some pipe sizes. So let's switch the view to the Z direction with hotkey Z. Move up, pan. We want to make it 8 inches from, basically from this valve to 42. So press E for the element select. Grab your window from that valve to element 41, 42. Make sure we get all that. And now change the size, right click, change member, go, it's currently a 6-inch standard, take it to 8-inch standard, and we do this and the size changes. Now we're going to need reducers here on either end, so let's double click this 34 to 36 and double click 41, 42, and we want to make those reducers. Now the, it wants to, you want to define the reducer. It's having the size of its, what it is at its from node. So these are correct. This will go from 6 to 8. This will go from 8 to 6 because it's defined as an 8. This is defined as a 6. Let's do right click and element type, and we'll go reducer here and double click here. And if we want to define specifically what the second diameter and wall thickness and alpha is, fine. Otherwise, we'll just take it from the model. So if we say OK, now we're looking at a couple of reducers here. What's left, we now want to make, we have to define these two here as 4 inches, and we have to put valves in here. So select this element, and then control click and select this element. Go down and go member type, and say 4-inch standard here. And then we just want to break it. So we say right click, break, and our element distances are going to be 550, 500. So we get a break, and then we want to make these in the middle valves. So select there, control select here, and go element type, valve rigid, click that rigid element, and we'll call these 2,500 newtons weight-wise. And looks pretty good there. So we build our model very quickly. Oh, we want to add just a connection here. So zoom in, dropping off this T at 32. We do node connect, select that 32, it turns orange. Now if we do Q for quick entry, it will build it off of that 32. We want to go in the Y direction, which is 330 millimeters, or say 230 millimeters. We're good. And then we want, oops, I put that in the plus direction. Hit undo here. Select again, node, select, quick entry. We make that minus 230, enter. And then just in the length direction, make it 100, enter. And close here. And this piece, we're going to make a flange. So we connect. Element type, valve and rigid, and we'll make that 150 newtons, and we should have our flange here. So now we build our model very quickly, much quicker than if we'd simply typed in data from one page to the next. If we want to run our analysis, we set up our load cases, go input static load cases, and we can initialize our load cases. It will look and see, for example, that we have a spring hanger that needs to be designed. So set up a restrained weight case where the hanger is rigid, a free thermal where it's free, select a spring, and then do an operating sustained and expansion case. We could go through and demonstrate that, but no need. Things, again, just verify that our operating conditions have propagated through the model. They have. You can change these graphically if we want to. For example, if we want to change the temperature condition on these 4-inch lines, we can select those. How do we know that they were selected? Let's stop showing the pipe loads. We've got them selected. We could come down here and we could say piping loads, temperature, and we could edit that load case and say this was only 250, for example. And now that when we show, we see that that is obviously a different temperature. Other things you can do with your graphic editing, you can renumber your nodes. We'll do that in a moment. Why don't we do that now? These node numbering is a little bit scattered. We go 32 to 52 to 86 and things like that. If we want, we can select the part that we want to be renumbered, and it can be the entire model or any part. We do the entire model, we can do Control A, which is select all, or we can simply grab the whole thing in the window, which selects all. And then when we say renumber nodes, that's where to start, what our increment would be. And if we do that, we now have a more reasonable numbering system, 10 to 20 to 30 to 40 to 50 to 60 to 70, etc. Other things you can do graphically, you can change the dimensions of any element. You can change the members. We did that. Material you can change, element type, bend, valve, rigid, expansion joint, reducer, T, SIF. We used 4 of those 5. Piping loads, we can put any temperature, pressure, fluid, uniform on there. We can give these line numbers if you want. Select various parts, and then you can search and select via that line number. You can select by member. You can say, show me, and select only the 4-inch pipes. Okay, which is an easier way to work. Or, as I said, you can copy. We've done that, break, things like that. You can hide if you need to get in and work in an area. You can hide particular elements. Then you can do things like inverse hide. Okay, invert hidden. Then you can do things like obviously bring them all back. So we unhide all. Okay. So there's a lot of things you can do graphically. Should be a lot of fun, a lot faster, a lot more efficient, things like that. So anyway, good luck with this. And again, any questions, let us know. And we appreciate the time that you're putting in to help beta test this. Thank you.